This is part 2 of our video on proofs, and we are now going to take a look at a logarithmic function question. So for this question, it says, prove that log base 5 of x to the power of 3 minus log base 5 of 512y to the power of 3 equals 3 log base 5 of x over 8y. I will tell you right now there is a typo that I just noticed. There should be brackets around that x cubed, just to follow proper formatting. Okay, so when I'm doing a proof, it is like a little puzzle for us to solve. I already know what the answer is, right? They told me what the expression is supposed to equal. It is now just my job to try to figure out how to get it there. So I would start by choosing what side I want to start to work on. It doesn't really matter because if it's not working out, you can always go work on the other side. But I am going to start by choosing either the left side or the right side to work on. Now, when I look at it, I look for which side looks like I have more to do. What has more operations, right? What maybe looks a little more complicated. So when I look at it, the left-hand side to me has 2 terms. The right-hand side has only 1, right? So if I choose the left-hand side, I'm going to have to find a way to combine those 2 terms into 1. If I choose this side, I'm going to have to find a way to take this and break it into 2 terms. So I think I might start on the left-hand side just because there's a little bit more going on. So I'm going to start by writing LS, or left side equals, and then copy down what the left side is, including that bracket on the x cubed that I forgot to type. All right, so I have log base 5 of x cubed minus log base 5 of 512 y cubed. And then the other side, I'm going to write it down, is 3 log base 5 of x over 8y. Okay, I did put the log rules here to help us out. They are also on our green sheet, and we're going to see if we can find a way to use them to help us turn the left side into the right side. So as I mentioned, this has 2 terms, this has only 1. So we're going to have to find a way to combine these 2 terms together. Now, are they like terms? They have the same base, but they have completely different arguments, so they are not like terms, so I can't just add them that way. But we do have a rule for subtraction of logs that says if you have the same base, which we do, we can combine 2 logs into 1 by dividing their arguments, which kind of makes sense because the other side has some division in it. So I'm feeling good about that. So we're going to try to use this rule and combine these 2 logs together into 1. So it's going to be log base 5 of x cubed divided by 512 y cubed. Right? They're different letters, so I couldn't really divide them. Now from here, I have a choice. I have a single term, I have a single term. I can keep working on the left-hand side in an effort to try to turn it into the right-hand side, or I could go work on the right-hand side and try to see if I can make it equal where I'm currently at with the left-hand side, right? So when you're doing a proof, you can either pick the left side, work the left side until it equals the right side. You could choose the right side, work through the whole right side until it equals what the left side equals, or you can work both sides until you get them to the same point, which I think is what I might try doing here, right? We could keep working this side, but I kind of want to give this one a try. I have 3 log base 5 of x over 8y. So something I notice about this compared to this is that this has a number in front and this does not. So there is a rule here that says if you have a number in front of your log, you can bring it up as a power on your argument. So I'm going to try that. This is going to be log base 5 of x over 8y to the power of 3. Now that power of 3 is on the entire argument, meaning the x, the 8, and the y are all to the power of 3. So this is going to be x to the power of 3 8 to the power of 3 and y to the power of 3, and I lost my 5. Sorry about that. Now x to the power of 3 is just x to the power of 3. So I have log base 5 of x to the power of 3. 8 to the power of 3, according to my calculator, is 512. And then y to the power of 3 is y to the power of 3. And I don't know if you noticed, but that means that where I got to on the left side is now where I got to on the right side. So these two are actually equal. So my left side and my right side are equal. So I can stop there and say I've done it. So therefore, left side equals right side. And then if you want to seem a little bit fancier, you can add the QED, which just means, which is what we were meant to prove. If you don't want to add it in, that is not a big deal. Right? So you can work all one side, or you can try working both sides until you get them to a point where they're equal. All right, there is a second log question for you to try, and then I will catch you in the next part on trigonometric